Okay, number 17 and 18 coming at you. These are actually a little bit easier questions, but they still have some real validity because there's different versions of lines that we're going to be dealing with in the first couple here. And so it may have been a little bit since you thought about the different forms of a line. So here we go. We have a line. We want to find the general form of an equation that passes through this point right here that is parallel to this one and perpendicular to that one. So let's take a look at that. So what I know is if I have 2x minus 3y is 5, a pretty good idea to do would be to move this around a little bit in order to isolate that slope. Because again, if we have parallel lines, we want equal slopes. And here in perpendicular, we want opposite reciprocal slopes. So whatever that slope is, we want to change the sign, flip it over, that's going to make it perpendicular. So if I were to isolate y, you could see right here by dividing by -3, this line could be rewritten in slope-intercept form. Now, a lot of people love slope-intercept form because it gives you the slope, which is great, but that's an ugly equation because you got an intercept of 5/3. You don't want to graph that. That's awful. So remember, we have this version right here, which they're calling general, but that's also, you could call it standard. They're pretty much the same idea. There's a tiny little difference between them, but I use both of them almost interchangeably. But my favorite version of a line is the point slope formula. So if you have a slope of m and a point x1, y1, the point slope formula says take any value of y, subtract the y1 value, then take your slope and multiply it by x minus x1. So we're in pretty good shape because this problem tells me to go through the coordinate 2, -1. So it's telling me to go y minus that y value, x minus that x value, and of course, for this particular problem, I want the slope to be exactly the same as that original problem, which is 2/3. This is actually a 100% valid problem, and we usually are going to utilize that solution and walk away from it because normally point slope is actually the optimal answer of the question. But we do need to sometimes be aware that we could move things around a little bit. So I think what I'm going to choose to do, change my mind a little bit, I'm going to multiply both sides by 3. Because part of standard and general form is to not have fractions. So I just kind of eliminated that piece. So the second part of standard is that we want to make it look kind of like this original problem right over here, where the x's and y's are on the same side together. Move that 3 across. So the stipulations are that x's and y's are on the same side together, that there are no fractions to be found in the problem. It looks like ax plus by equals c, but the last step is that this leading value has to be positive. So I'm going to multiply both sides by a negative, and that should be that answer. So again, if you're working on something, it's very easy to go into Desmos or a graphing calculator and graph both of those problems, but you can kind of see. This is kind of funny. I just got the same answer back as the original problem, didn't I? That's really funny because the original problem actually went through that point. I just figured that out. So these are not parallel. This is a bad question. That point is actually on the line. I've never seen that before. That's funny. Okay, that point is actually literally on the curve. Therefore, this is not a parallel. It is actually the same line. So it's kind of a bad question. But oh well, we're going to move on. Now, when I go for perpendicular, I'm going to play the same game. I have the same exact point, y plus 1. I've got the same point, x minus 2. But over here, I'm going to use the value of -3/2. Remember, opposite and reciprocal. So just as before, let's multiply by 2. That's going to give me 2y plus 2 is -3x plus 6. A little bit of a movement around in here, and all of a sudden I have my perpendicular. And that's going to have that opposite and reciprocal slope. Life is pretty good. Again, sorry about the bad question here. This is funny. I've used this thing quite a bit, but I actually never even noticed the fact that we got the same exact answer back. I just got the answer and moved on. So I'll have to mess with that one for later. All right, so I was hoping to do just 16 and 17. I think we're going to hold off number 18 until the next one. Hopefully that was helpful to you. Other than the bad question there, I'll see you for the next one later. Bye-bye.